Okay, we're recording. Let me go back to my slides now. There we go. Welcome everyone. Thank you so much for joining me. I know after work hours is so tough. And if you are in a time zone, I'm in Central Time. I know we probably span a lot of time zones. If you are in any time zone like me, it is already dark. Daylight is gone and it is hard to sit on your computer for another hour. So thanks for joining us. If you want to introduce yourself in the chat where you're located, maybe what you teach, that would be great. I'll introduce myself in just a second here. I gave the link to this landing page and we fixed the permission issue. So this just has the website that I'll be walking us through, the slide deck from today. If you want a PD certificate for this, I know people really enjoy those. There's a form here that you can fill out, and I'll try to get those out by Monday, if possible. And then here's all the Future of Wind Farms resources here, and I'll walk through how to access those in just a minute. So the plan for today, well, first let me introduce myself. My name is Elise Thurber. I work on the Data Puzzles team at the Series Center for Education, Evaluation, and Engagement. Sorry, we have a name change, which is why I always hesitate. I get the order of the E's wrong. So we're now CEEE. This slide says Series Education and Outreach. Series is a Earth Science Research Institute. It stands for Cooperative Institute for Research in Environmental Science at CU Boulder. So I have a biology background, and then I was a classroom high school science teacher for many years here. And then I got hired to work with scientists at Ceres to turn their science into classroom products. John Griffith, if you are familiar with Data Puzzles, you've probably met John, at least virtually. He is the originator of Data Puzzles. It was his idea, and I'll talk through his story a little bit here. Dr. Anna Gold is our boss here at CEEE, and has been really involved in the development of Data Puzzles. And then Amy has been our graphic designer, and she makes really awesome graphs and images for us. Melissa Bratton has worked closely with us. She is heavily involved in ambitious science teaching practices, if you're familiar with that. She is an assistant professor in the School of Ed at CU Boulder. And then our collaborator on this data puzzle that we'll be talking about today, Wind Farms of the Future, is Dr. Julie Lundquist. She was formerly, sorry, I'm originally from New England, and those R's at the end are like really hard for me to pronounce correctly. Formerly at CU Boulder, she's now at Johns Hopkins, and she's an atmospheric and oceanic sciences researcher. I just want to acknowledge a few other organizations that we've worked with and that have familiar names and everything. We've talked to them before. So Data Nuggets, we've actually have made a data nugget with some data originally in the Mosaic curriculum. And so worked with them early on, and just want to acknowledge their part in helping to conceive of data puzzles. And PhET simulations here at CU Boulder as well. And then the Lamont Doherty Geoscience Data Puzzles have a similar name, and we have collaborated with them in the past as well. So today I'm really just going to go through the Data Puzzles framework with ambitious science teaching practices in the context of this one specific data puzzle in the Wind Farms of the Future. And we'll engage with it a little bit, but this is going to be, like fairly quick, looking at this framework in this puzzle. So really the inspiration for data puzzles came from this Mosaic expedition 2019 to 2020 years. This was a really large research expedition on sea ice, and our part on our team was to create curriculum from this. And there were some really cool data sets that we felt were buried in these sort of longer school units, which are really valuable, but we wanted to shine more of a light on these data sets and develop something that was a little shorter to digest. So a couple days in your classroom to really get students diving into data and looking at some of the important findings coming out of that expedition more quickly and more easily to fit into your existing curriculum in your teaching. And so that combined with this ambitious science teaching framework, if you're not familiar with this, this is what I learned about in my teacher certification program. It's become really popular. They have these 4 particular practices that they have developed: planning for engagement with science ideas, eliciting student ideas, supporting changes in thinking, and then pressing for evidence-based explanation. And the whole idea here is really that you're using student resources and experiences that they already have and bridging that with new knowledge to really cement learning in students. And so in working with those ambitious science teaching practices, and here's just a couple extra bullet points on what those are. We worked with Melissa to sort of reframe those in a way that works for shorter engagement, which is what data puzzles are. So ambitious science teaching practices can be extended over a larger unit, but we had to adapt them for shorter. And you'll notice that what happens here is, if you can observe these colors here, is that this planning for important ideas, really, this gets taken off because we have done the planning for you. So this is teacher facing, right? And so we've done this planning, and what we've replaced it with is identifying important science ideas and having students identify those important science ideas. So in our consultations, this is where we really kind of landed on adapting those practices into shorter resources for our own framework. I'm just going to talk through those a little bit. So every data puzzle starts with eliciting student ideas. So again, this was the second step, and the AST practices is our first step. And these whiteboards here are meant to represent sort of the tasks involved in this framework. So this is where students' resources and their experiences, this is where you're bringing those to the forefront and making those visible. And so we can use those later on in the lessons. So this is where we have what we call an opening scenario, which is often a discussion question. We'll talk about how to facilitate this in a little more detail in a bit. But this is, we give a prompt and we want students to bring their experiences and their resources in response to that. This is where we have students working together and discussing different ideas, and where we bring out that science language. And then we move into our second step, identifying important science ideas. This is where students are starting to connect their own resources into a new scenario, the scientific investigation. We do that through interactive readings. Students make initial conceptual models of the investigation, and students make predictions about what they think the investigations will find. Then we move into supporting the ongoing changes in thinking. And this is where students test their ideas against actual data. So they're analyzing data, identifying patterns, and using that data and that evidence to revise their predictions. So going back to their original ideas. And then the final step is constructing evidence-based explanations. So this is where students are summarizing their ideas related to the investigation, really where they're going back and creating a revised model that they had already created in the identifying important science ideas part, and bringing all that evidence together into their model. And then we always have a digging deeper portion at the end of the data puzzle. This is either applying what they've learned in the data puzzle into a new scenario, or sometimes it's looking at a different real world context of why this investigation was important. I'm going to pause here, and I want to walk us through the website. So how to access this. So we'll be talking about wind farms of the future. So talking about that framework in a specific data puzzle in just a minute. But I just want to familiarize with us with how to navigate this. So this is the data puzzles website landing page, and all the collection of data puzzles, and there's about 15, is in this resource collection. You could also access it through this collection tab up here. And here you can search, or you can filter by theme. I find it easier to search, but if we have 2 wind data puzzles. So windstorms on the front range, and we'll be talking about wind farms of the future here. I just wanted to point out a couple other things because I went through our framework really quickly here. We have more extensive documentation in this framework tab. It goes through more slowly. We have classroom videos of these practices, each of these practices in action in a classroom. And we also have these strategy documents that have some really like rich and good pedagogy and teaching ideas in here. I really like back pocket questions when I'm working with students. And so we also have included those in these guides. So let me go back here. So I just wanted to point out. Those are sometimes a little bit overlooked. We have additional recordings and webinars in this tools section, just so you can see that. But I'll go back to this wind data puzzle here. Okay, so wind farms of the future. And then it will bring up the homepage for this one data puzzle. And all of these look really similar. They have context, a little background information, what students do. And then we know from some website analytics that people go to this resource folder really quickly. So I'll point that out in a second, but there's more descriptions of what is in that data puzzle down below. So all the separate documents in this folder are listed below, but people just really like to go to the folder and have everything all together. If you're worried about people want to modify stuff, I would always modify my own thing. So you can download this whole folder, or you can go in and make your own copies of some of these things. So if I really like to modify the slide deck primarily for my purposes, just because I have routines with students. So you can go and make your own copy of these slide decks. I'm not going to do that right now. But so you can have that and you can adapt that for your purposes. I want to walk through the teacher guide really quickly. We try to keep these teacher guides fairly short, 3 or 4 pages at most. But this breaks down the different steps of the framework in the teacher guide. So part 1, part 2, part 3, part 4. Some background information here. So the investigative question, any learning goals, if it aligns with some NGSS principles, those are in here, and any prep you have to do. And then the teaching guides are fairly short, but it does break it down by the different steps. So it's easy to walk through the framework. And we have sometimes some teaching notes and suggestions in there, and then additional resources. In the slide deck, I'm going to walk through the slide deck in more detail with you today, so I'm not going to spend much time in there. I will point out that there is stuff in the slide deck that is separate from the stuff in the student worksheet. So we think those things should work together, but they shouldn't be identical. And then there is an answer key in here. So students could potentially find that just so you're aware of that. But when we see the questions, you'll see that they're not, the answer key wouldn't be that helpful for them because it's not multiple choice questions. And then here's the student worksheet. I'm just going to open that really quick. I just wanted to point out that there are pauses in the student worksheets. And so we have videos linked in there. If you are a teacher who likes to give your students digital resources, they could watch the videos directly from here. If you were to print it out, you may want to make a copy and take these out. I'm going to point out that this video it's a really good one. It comes from UCAR, which is an NSF, a federally funded organization, and this is about climate change. I'm not going to speculate about what's coming in the next year, but if this is a video that you like using with your students and you want to keep access to, this may be a video that you want to either download. Sometimes you can download YouTube videos or sort of screen capture the video for for use next year. But I'm not expecting this to go down, but that is just, I've had people ask me, and better safe than sorry, I think. This is the student worksheet. All right, I'm going to go back to my workshop slide deck here, unless there are any questions about how to access anything from the Data Puzzles website. No. Eva, do you need me to send you the landing page? I can do that. All right, popping that in the chat there. Eva, that's the landing page again. All right, let's dive into wind farms of the future. So the eliciting student ideas portion of this. So again, this is where we get students to bring their own experiences and resources about the opening scenario. There are different ways to facilitate this. Some teachers use it as a warm-up prompt for their class, and they'll respond, they'll write something first, and then they'll do discussion later. Some teachers like to do think, pair, share. Some do whiteboards in small groups, or big like butcher paper, and they write down their ideas. These are not in the student worksheet. So this is a slideshow only portion, because this is really meant for getting students' ideas out and discussion. So the opening scenario for this one is, I want you to think back to a time and tell us the story of the windiest day or windiest moments that you've ever experienced. Where were you? Is it usually windy there? Is that normal? And what did you do? I don't know if anyone wants to share their like windiest days in the chat, but I can tell you mine. I was in Colorado for a year, and I took my kids up Mount Evans with my very elderly Duncan. I don't know why I thought it was going to be okay for everyone to have a great time and take a picture at the top, but it was probably the strongest wind I felt, and my kids were very, very complaining about it. The views were gorgeous, but I really couldn't enjoy it because my kids were just absolutely losing their mind with the wind. And I haven't been there before, but I imagine that's probably pretty normal. So yeah, you want students sort of talking about things like this. This is what one teacher, how they facilitated this. So they had big pieces of paper, and the prompt was in the middle, and they had students write down the story of their windiest day. And she wanted to pay particular attention to what students saw, what they felt, their actions, their locations in their stories, and then they talked about it. Oh, wait, what's, I don't know what the edge is. I'll ask you after. That sounds, I'm so curious about this. Thank you for sharing, Eva. Oh, in New York City. I bet. Oh my gosh, I bet they're like wind tunnels and stuff too. So after this sort of initial discussion of prompts, we want students to have a chance to talk with each other about their experiences and to sort of start to extend that a little bit. So we have a turn and talk where we want students to think about what other landscapes besides the ones from their personal experience here do they think might be windier than others? Can they see some themes from their experiences start to emerge? Where were they? So I mentioned mountains, but you might start to see patterns in the data, like near open water on the shore. That's often a thing that people bring up. Maybe people aren't talking about the forest. So maybe we can see that there's starting to be some commonality to where students are identifying as being really windy places, and starting to transition into the next portion of this. There's a little bit more background context before students go into what we call the puzzle plot. And so we're setting this up. And so scientists and engineers are looking to learn more about why some environments are windier than others, in the hopes of identifying suitable locations to build future wind farms, so areas where there are many wind turbines that are grouped together. And there's a couple images. And with that transition, students will move into, oops, come on, computer. Oops, okay, now it's gonna do all my clicks all at once. Thank you so much. Okay, and our slide introduces our featured scientist here, Dr. Julie Lundquist. and breaks down her research. So she uses different instruments to measure wind in different locations and at different altitudes in the sky, and she uses it to predict wind conditions and how they'll change. Her research has been important in determining where wind turbines should be placed in order to produce the most electricity. And we have a little personal background about our scientists. So Julie says that she studies wind because she thinks it's powerful and beautiful, and she likes helping to ensure that we use renewable energy in the best possible way. And so from there, students go into identifying important science ideas. And this is primarily through our interactive reading we call a puzzle plot, where students start to identify the big important science ideas. So they're connecting the science ideas from the reading back to the opening scenario. They're summarizing the key ideas by creating a sketch, an initial model, and making predictions about the question that the scientists study. There are a lot of different ways you could facilitate this portion. The most popular we've seen is having the whole class read the puzzle plot aloud. But there's also small group readings, and teachers like to use any close reading strategies that they already use in your class. So keeping that routine. We recommend just one reading strategy for this because it comes back into play afterwards. So we ask for students to circle the question that the scientists are trying to answer and to underline the similarities between the reading and the opening scenario. And this is because after the puzzle plot, there are a few summary questions. And if students have already done these two things, they are well set up for those questions on the student worksheet. So this is what the puzzle plot in the worksheet looks like. And I can go show that as well, but I want to just point out a couple of the big science ideas that are contained in that puzzle plot. So that puzzle plot does talk about burning fossil fuels resulting in increased greenhouse gases that are causing global temperatures to rise. It talks about the need to transition to clean renewable sources of energy like solar and wind, and the want to increase construction of wind farms, but needing to figure out where to do that to be the most efficient. And then it starts to enter into the relationship between surface roughness, which is a measure of how much stuff there is on the landscape, and how tall it is. Like essentially, does that slow wind down? So having a lot of stuff on the landscape slows wind. And the need to understand the wind patterns before we can build more wind farms. Let me go back to the student worksheet that I had open at the beginning. So the puzzle plot is not a long reading for students, which is why so many classes feel that they can just do a whole group read aloud. And it's broken up with some images and some graphs. So it's about 2 pages. I want to point out this graph embedded in there. So usually what teachers do is they sort of pause, watch the video, or they pause and they look at this map more closely with their students. And so this is a map of the current wind farms in the United States as of the date of this creation of this map anyway. And so it's a good exercise to ask students to start to pick out the patterns, because in the next section, they'll be looking at wind speed maps. And so they can start to piece together that we've located these wind farms. They're kind of clustered in this plains region here. There's a few elsewhere. But if they can start to pick out those patterns now and talk about that, that'll be beneficial later in the data puzzle. And then here are those post-reading questions. So there's some thoughts on the type of landscape and what they predict wind speeds are like there. And here's the actual prediction. Well, they'll give an idea of what they think Dr. Lundquist will find. Okay, and then we move back here. There's a discussion prompt included in the slide deck to reconnect after that puzzle plot back to that opening scenario. So if they've done that underlining, they have their resources available to them to start thinking about surface roughness and windy areas. Okay, talk through this. This is just what the answer key for that student worksheet looks like. Again, that's available in that folder. And yeah, so it's not, if a student found this, I don't know how helpful it would be. But we do try to bury it in that folder so that it's not readily available. They would have to do a little bit of digging. All right, I'm ready to move into the next section here. Come on, mouse. I'm going to reload this for a second. So sorry. Let me stop sharing here. See if I can get that responding to me again. There we go. Okay. All right, we're back. Okay, so our third step in the data puzzles framework, supporting ongoing changes in thinking. This is where we're testing their predictions against authentic data. So this is where we're starting to look at the maps. There's a couple different facilitation strategies for looking at graphs. This particular data puzzle is a little bit different than the others in that it does use map data, which is a little bit more difficult for students to look at and interpret. Although I will say I've been really impressed by my students. I think maps are something that we're more used to using on our phones and things like that. But still the shading can be hard to interpret for students. So for graphs, people really like the whiz-whim strategy, what I see, what it means. For geospatial data, I've seen it recommended to do the see, think, wonder strategy. So asking students, what do you see? What does that make you think? And what do you wonder? So getting them to look at the data before they analyze the data. And you could have students work individually or in pairs or in small groups to analyze the data set. I'm going to spend a little more time on this data set than we would in other data puzzles webinars, just because this one is different from the others. So this one uses the Global Wind Atlas. And let me put that link in the chat. I'll just give you guys a minute to play around with that. And this is what I would do with students. Students always want to like get in and get messy in there. So this is the thing that I do with students. I just say, okay, have a look around, play for 5 minutes, and then we'll come back together. I'm not going to give you 5 minutes because this is really quick, but I'm going to give you a few minutes to look at that. So this prompt says, explore the Global Wind Atlas, and then be ready to discuss the following prompt. How could you use the Global Wind Atlas to learn more about the relationship between wind speed and surface roughness in the US? So I'm going to open that up. So when you first open this up, you get a whole world view, and you can use your mouse to pan over. This opens up with mean wind speed, and the legend is down here. So the really dark red colors are around 10 meters per second, and then the bluer is slower, 1-2 meters per second, and then green and orange are sort of in the middle. I'm going to point out this second, I don't know if you guys can see this in the bottom of my screen. This second legend right next to that color bar says M on it. That is how high they're measuring average wind speed. So it opens on 100 meters for our purposes. That's what we want, because that is the average height of a wind turbine, is 100 meters. You can occasionally get really super tall ones. That would be 150 or 200, but 100 is the most common. So that's okay. We won't adjust that at all. You can zoom in using this plus and minus sign up here. Sometimes it takes a bit to load once you've zoomed in, but that's okay. And then, so wind speed is what it loads on. The other layer we're going to look at, and we're going to have students look at, is roughness length. There we go. So this little information bubble tells you that roughness length is the roughness of the terrain surface. So this is what we were talking about in that puzzle plot. So the darker green is more rough and the lighter green is less rough. And so, this coastal area is less rough than the Appalachian Mountains here. The plains area is less rough than this mountain area, than this really woodsy coast over here. You can see the patterns in roughness and compare to wind speed, where we can see that it's really high along the coast and in the center of the US. All right, I'm going to go back to the data puzzle here. So that's how to navigate that wind atlas. I would give students a little bit of time to play with it and then show them how to navigate it and point out the data sets that you want them to look at. And then I would lead a little bit of a discussion about how you would want to learn more about that relationship. And then after that discussion, the student worksheet has a few questions, and I'll go over to that. So a few questions on how to analyze that data. So these are 4 through 6 here. I forgot to mention that one thing we have in place here for is if you give your students digital copies of things, to ask them to take a screenshot of the global wind atlas. If you don't always want them in this website playing around with it, I think that can be really helpful to just have them pop a screenshot in here that they can refer to later. And also, this can be, I don't know how good your school's internet is. Mine wasn't always like the speediest, and so it prevents any sort of like loading issues if they're zooming around by just using a static screenshot. So having them place that in there for roughness, length, and wind speed. And then there are a few questions that ask them to really like dig in and look at the patterns that they're noticing and trying to understand how those two variables relate to each other and create a rule to describe the relationship. So how does surface roughness impact wind speed? What are you noticing? And then they'll go back and revise their prediction about the initial question. And then give evidence from that wind atlas that supports the changes that they're making in their prediction. All right, and then any questions about that global wind atlas before I talk about this last step in the data puzzle? Are there any summary questions you'd ask after letting them play? Yeah, so the summary questions in the student worksheet, I think, are really good after letting them just play around. So it really asks them like, which areas have the highest roughness? Which land areas have the lowest roughness? So just starting to like summarize the patterns that they are seeing and start to think about why the patterns are leading to this difference in wind speed. And then this rule is a really good summary question. So getting them, I would probably, I don't know, depending on your students, I mostly taught high school, but I think I also student taught in 8th grade. I might give them a sentence starter in here. Like what are the wind speeds where you have high roughness? And then what are the wind speeds where you have a low surface roughness? Like getting them to getting your students to elucidate a rule can be a difficult thing to do without a sentence starter, I think, if that's helpful. Okay. Cool. And then we're in the last step of the data puzzle. So this is where we're constructing evidence-based explanations. So this is where they're taking their new understandings and science ideas and constructing a written explanation. So sometimes in data puzzles, we do conceptual models, they draw it, and sometimes we do more of like a written sort of summary, depending on the data set and what it lends itself to. For this one, it made more sense to do a written explanation and a conceptual model because we were working with map data. We were working with, the geospatial data that was a little bit harder to conceive of in a model that would be different and separate from the map. So we've chosen to do a written summary here. And so this prompt asks students to imagine that they're part of the research team and Science Journal has asked to write an article about the future of wind farms. Tell your readers about how changes in surface roughness impact wind speeds across the United States. And then based on what you've learned, explain where you think future wind farms should be constructed. So you could even ask students to sort of on a blank map draw where they think future wind farms should go, or you could go back to that map from the puzzle plot that has all the locations of wind farms and evaluate whether students think that those are good locations, should additional ones be put nearby. You could do a couple different things there, but the idea is that we're getting students to use the evidence that they've learned from looking at that data to summarize it really, and to go back and draw connections to the investigative question. All right, and then we always end with a digging deeper portion. This one happens to have a video in here, and I think that this video, just because someone asked me about this recently, I just want to make sure that this video is from, this one's from the California Energy Commission. So this video seems like it should be fairly, this video should be fairly safe, should be available for a long time. I'm not worried about this video. So ask students to watch a video about a California offshore wind energy project and evaluate and think about what are the advantages and disadvantages of offshore wind energy. So they should be able to go back to what they've seen and to see that the coast is actually, it's really windy, there's no roughness, it'd be a really good location for wind farms, and to take that learning and apply it to this context of the California offshore. And these little boxes on here are actual, these are some responses that we've seen from students, some questions that have come up in response to this prompt. What questions do you have about offshore energy? So just so you can see what students have in the past had questions about. They want to know what happens to wind turbines if earthquakes, tsunamis, or other natural disasters like hurricanes occur and knock over the wind turbines. If people are dependent on them, won't it make it worse if something were to happen? So getting into some disadvantages. And then how much energy will it take to actually build turbines in the first place? So students are really starting to have some good questions here related to wind and energy. I see a question in the chat. Do you have any East Coast information videos to recommend? There's so much planned offshore, New York, New Jersey. Oh, so we're actually, I'm going to plug this a little bit. It's not finalized. As part of these data puzzle workshops that we're doing, we're trying to have a scientist talk in conjunction. December is a really busy month with a lot of conferences for scientists. So we are having one in January. And she's not New York, New Jersey, but she does work with the Block Island, so New England coast offshore energy farm. So I think that they'll be talking about that. Details coming soon. If you are not on our newsletter yet, this is where we'll announce it first. I can put this link here. But the scientists will have some really great resources in talking about those coastal energy projects. So yeah, we'll have a scientist talking in January about some, an atmospheric scientist at least talking about some wind projects, TBD. Unfortunately, Dr. Lundquist was not available for us to do that. So we are getting a scientist that used to work on her team. So it'll be related. So got a couple months here to maybe work through this data puzzle with students, or maybe wait until after the scientists talk. But we are trying to pair those things together. And then we have a new, since I'm on this slide, we have a new webinar for a new data puzzle in January, also about the polar vortex. So again, the full details on that are TBD. And yeah, just thank you. If you need a PD certificate, let me get that link for you in the chat here. It's also on that landing page that I sent out earlier, but here is the Google form. If you fill that out, I will get you a PD certificate by Monday. And yeah, any questions for me? Cool. Well, thanks for being here all.